Okay, let's look at a couple examples from the 6.5 homework. As usual, I'll try to do evens that are similar to the odd ones that you've been assigned. So let's just look at 2 and 4 to start with. So question 2 is just 1 over x from 1 to 4. They just want you to find the average value. You don't even have to draw a picture. I always like drawing pictures, so let's see, 1 over x looks like this. And from 1 to 4. Okay, and we're trying to find the average value. Obviously at 1 it's at 1, 1, and at 4 it's at 4, 1/4. The highest it ever goes is 1, and the lowest it ever goes is 1/4. The average should be somewhere between 1 and 1/4. It kind of looks like it spends more time lower than it does higher, so I'm guessing the average is going to be closer to 1/4 than it is to 1, but let's find out. So we know the formula. So we need the integral, so for number 2, we need the integral of 1 over x dx, and then out front we just need 1 over 4 minus 1, and we're integrating from 1 to 4. So we know how to integrate. So the 1/3 just sits there as a constant multiple, and when we integrate 1 over x, that integrates the natural log of x. I'm evaluating that from 1 to 4. So this becomes 1/3 times the natural log of 4 minus the natural log of 1. The natural log of 1 happens to be 0. So we really are just looking at natural log of 4 times 1/3, or divided by 3. And really that is the answer. That's probably what the back of the book has. I'm just a little curious decimal-wise to see if it's closer to 1/4 or closer to 1. So natural log of 4 divided by 3. Let's see, I need to be in scientific mode here, so I get a natural log key. So natural log, natural log of 4 divided by 3. About 0.46. Okay, it's only a little bit less than 1/2, so I was not completely right about the average, which is probably partly due to the fact that my drawing is not like ruler accurate there. Okay. Anyway, that was number 2. Let's go ahead and do number 4 as well. And for number 4, we've got a slightly more complicated function. I'm not going to try to just graph it by hand. You can graph it on the calculator if you want to get an idea of what's going on here. But 4 is going to take a little bit more integration work, but the same idea for number 4. It's from 0 to 2, so my multiplier out here is 1 over 2. And we're integrating from 0 to 2, x squared and square root of 1 plus x cubed dx. There's the setup. Now we just have to actually be able to work the integral. And it may have been just a hot minute since the last time you thought about u substitution, but this integral needs a u substitution. So let's let u be 1 plus x cubed, which means du will be 3x squared dx, and I can already see over here that I'm going to need to sort of rewrite this as 1/3 du is x squared dx. Okay, now I'm ready to rewrite my integral. So I've got 1/2 integral to, let's see, x squared dx is the same thing as 1/3 du. The square root of 1 plus x squared is the square root of u, which I'm going to write as u to the 1/2. And we're ready to integrate. I'm actually going to move the 1/3 out front, so let's call this 1 1/2 and 1/3 become 1/6, and then the integral. Okay, so integrating, increase the power. And divide by the new power, so u to the 3/2, and divide by 3/2 is multiply by 2/3. And we're not quite ready to plug in 0 and 2 because, as always with u substitution, it's not about u. Let's change this back into x's. Let's see, this is going to become 2/18, so I'll do that. And then change the u back into x. 1 plus x cubed to 3/2. And now we're finally ready to plug in 0 and plug in 2, because that 0 and that 2, those were x limits, those weren't u limits. Let's see, so plugging in, so we got 2/18. Plugging in 2 would give me 8/9 to the 3/2. And then plugging in 0 would give me minus 2/18 and times 1. So just minus 2/18. So let's see, we can do a little more work here just to finish this off. 2/18 reduces to 1/9. 9 to the 3/2, keep on this power over root, so the square root of 9 is 3. Cubed is 27. And 2/18 is the same thing as 1/9. So we've got 27/9 minus 1/9 would be 26/9. Average value for that function. Okay, so there's number 2 and number 4. And let's go ahead and take a look at number 10 as well. So number 10 has 3 steps to it. First is just find the average value like we were doing before. And then for part B it says find a C. Find a C such that the function at C equals the average value. That shouldn't be too hard to do once we know the average value. And then it says sketch the graph of f and a rectangle whose area is the same as the area under the graph of f. That seems a little bit weird, so let's talk about that a little bit. Let me remind you of, here's our definition of average value. And let me do a quick sketch here. So when we're talking about that, we're saying I've got some function going through here, and we're going from A to B. So from there to there. And we find the average value, but let me take this formula here below and let me multiply it by b minus a. So I can rewrite this as b minus a times the average value, which should just be equal to the regular old integral, which we know is the area under the curve. So the right hand side of my rewritten formula down here is just that blue shaded area, and the left hand side looks an awful lot like the area of a rectangle. Matter of fact, it is the area of a rectangle. The one part of it, b minus a, that's just the length here of the bottom. And we're just multiplying that by the average of the function. The average, who knows what it is, but maybe it's about right here. So we're just multiplying it by that value, which gives us a rectangle. And the theory is this purple rectangle now should have exactly the same area as the blue, as the area under the curve. Which kind of makes sense when you're talking about the average of the function, right? You kind of lop some of the top off the hill and use it to fill in this little valley space right here, and just kind of flatten out the curve to its average value. So that's kind of what they want us to draw in part C. All right, so let's go ahead and get rid of that, and let's see what we can do with our new problem here. Okay, so for part 10a, The first part of that's just finding the average value of the function. So over 0 to 4, that will be the interval, and then integrate over the interval the function. So that part again, not bad. We've got 1/4, so yeah, this is part A. We've got 1/4, we're going to integrate x to the 1/2 to go to x to the 3/2, and we'll put a 2/3 out there to compensate, and we're going 0 to 4. Let's see, this becomes 2/12, or 1/6. So it becomes 1/6. We plug in 4. Well, here, we'll just do 4 to 3/2 minus 1/6, 0 to 3/2. We'll do the full deal here. Square root of 4 is 2. 2 cubed is 8, so we've got 8/6, which is 4/3, and then this part's 0. So the average value of the function between 0 and 4 is 4/3. Part B now says find a c such that the function average, which is 4/3, is equal to the function at c. So they want the average to be equal to the function itself for some value of c. So we just need to figure out where the function is equal to its average. So we are good algebra kids at this point. We know how to solve this, so square both sides. And x is 16/9. Let's say the function should be equal to its average at 16/9. And part C then, so that was B. Part C says sketch the graph of the function, and the rectangle has the same area. Okay, so let's, for part C, it's just square root of x, so I know basically what square root of x looks like. You can, of course, graph that with some sort of technology, but I will just graph it by hand. Square root of x basically looks like this. And we were interested in going from 0 to 4. So we were going from 0 to 4. So the area under the graph, we certainly got that from 0 to 4. There's the area under the graph. We do know the average value is, okay, so here, let's get some points on here. This is the point, when you plug 4 into the square root function, you get 2. So this is the point 4,2. This is the point 0, 0 down here. We know the average value of this function is 4/3, a little bit more than 1. So on our vertical scale here, there's 2, there's 1. So apparently, let's see, I need a new color here. Let's go with this lime green. So 4/3 is about right here. So apparently, and this should come down to 16/9, by the way. That's where the function equals its average. But apparently, this green rectangle now, I shaded all this in, that green area should be the same as the purple area. And again, it's like taking this whole red curve and just liquefying it, and it just melts down into a level surface and fills up the bucket that it's in from 0 to 4. Then it averages out, right? And that's the height that it averages out at, and that's the rectangle that matches the average. All right, and we are done with chapter 6.